All right, greetings, Chem fam. We are back. We are on Stoichiometry worksheet number 1. This is the back side. Thought I would try out a couple problems to walk you through just in case you needed the help. This reaction is octane is reacting with oxygen in order to create carbon dioxide and water. That's a combustion type of reaction. And if we want to balance this, there's 8 carbon on the reactant side. So I'm going to put 8 carbon on the product side. 18 hydrogen would be 9 times 2 hydrogen. That is a 9, forgive me. And that would end up giving me 16 plus 9 oxygen, which would be 25. So this would be 12 and a half. All right, 12 and a half times 2 would be 25. So that would be a balanced equation. Now that's not very pretty, neither is my handwriting. So I'm going to rebalance that out by doubling everything so that the 12 and a half becomes a whole number. So to do that, I'm going to get rid of the 12 and a half and I am going to double it and make it 25. All right. I am going to get rid of my 8 and double it and make that 16. I'm going to get rid of my 9 and double it and make it 18. And I'm going to get rid of, don't forget, the 1 and double it and make it 2. So now it's 2, 25, 16, 18. Everything is balanced. All right. Looking at number 6 here, I have 20 liters of H2O. And I want to know how many grams of carbon dioxide that is. So I know I'm starting with a volume of 20 liters of H2O. And eventually I want to end with my grams of CO2. All right. So that means I'm starting with the volume. And that's the volume of object A. And since CO2 is another object, I'm going to end with the mass of B. Now, if I look at my mole map and I follow from volume A to mass of B, I'm going to have to go to moles of A island, to moles of B island, over to mass of B island. And let me move that over. Boom, like that. All right, so where do I begin? Well, from volume A to moles of A, it says that I need to put 22.4 liters of H2O on the bottom for every 1 mole of the substance. And the substance I'm working with right now is H2O. When I go from moles of A to moles of B, it says to put moles of A on the bottom and B on top. So that means I'm going to have moles of H2O on the bottom. And I'm going to put moles of the next object, object B, on the top, which is CO2. Now, what numbers do I use for this? Well, I use the balanced equation for multimole ratios. So next to water is an 18 in the balanced equation, so I'm going to use 18. Next to carbon dioxide is a 16, so I'm going to use a 16. After that, now I need to go from moles of B to mass of B island. To do that, I need to multiply the molar mass of carbon dioxide. Let me give myself a little bit more room here, and let's do that. I'm going to put, according to the mole map, moles of CO2 on the bottom, and the molar mass is going to be carbon plus 2 oxygens, and that ends up being about 44.01 grams of carbon dioxide. All right, double check our units. Liters of water cancel out, moles of water cancel out, moles of carbon dioxide cancel out, and we're left with grams of CO2, which is what we are looking for. So when I throw that through my calculator, remember, I'm going to multiply the top together and divide by the bottom for everything. And what I end up getting for a final answer is about 34.93 grams of carbon dioxide. All right? I used my mole map, I used stoichiometry, and my balanced equation to help solve that problem. Okay, looking at question number 7, let's get that ready to rock. I want to know how many grams of CH18, which is octane, reacts with 75,000 molecules of O2. All right, Well, I know that I have to start with a number, so I've got 75,000 molecules of oxygen. And in the end, I want to know how many grams of octane, which is C8H18. All right, to do that, it looks like I'm starting at particle island of A, particles of A, and eventually I am going to end up with mass of B, the next object. So to get there, I need to go to mole island A, over to mole island B, over to mass of B, and I'm going to use my mole map to figure that out. Okay, so let's do that. First things first is to go from particles to mole island. So let's do that. It says that I'm going to divide by 6.02 times 10 to the 23rd power molecules of O2 for every 1 mole of O2. All right. Next, I'm going to go from mole A island to mole B island. To do that, I'm going to use my mole ratios. It says to put A on the bottom and B on top. Okay, so A is oxygen, so I'm going to put O2 on the bottom. B is the new object, C8H18. And now I'm going to use my balanced equation to figure out what moles of each I'm going to need. For C8H18 up top, it's a 2. And for oxygen, it looks like it is a 25. All right, sorry, that's getting a little tough to read. Let's clean that up a little bit so you can see. All right. Now that I have my mole-to-mole ratio, the very last thing I'm going to need to do is go from mole of B island to mass of B island, which again leads just like the last problem. I'm going to end up with moles of B on the bottom, which is C8H18, and then the molar mass up on top. If I add 8 carbons plus 18 hydrogens off the periodic table, I end up with about 114.26 grams of C8H18. Okay, now that I've gotten to my end part, let me erase this to clear up some space. Let's double check to make sure I canceled everything right. So molecules of O2 to molecules of O2, the moles of oxygen to moles of oxygen, and the moles of octane to moles of octane cancel out. And when I throw that through my calculator, I end up getting an answer that is about 1.14 times 10 to the negative 18th grams of C8H18. You know, looking through this too, this part got a little bit confusing how I wrote this. This isn't CO2. This was molecules of oxygen. So that's MCO2 in case that was getting confusing. But overall, I used my mole map and I used my balanced equation to figure it out to get my answer. Hopefully walking through this a little bit helped. Check out the other videos too on how to use the mole map as well. That might be beneficial to you. But thanks for listening. Best of luck, Chem Fam.